Welcome to this session. This session you have to prove two problems which are testing on product of two determinants. So the first question is to prove that the determinant given in this form is a multiple of the determinant, this determinant here, and find the other factor. And then the second is to prove that this determinant involving trigonometric functions of cosine gives a value of 0. Now, the first one, so proof, check that if we have 2b1 plus c1, 2b2 plus c2, and then 2b3 plus c3, c1 plus 3a1, c2 plus 3a2, c3 plus 3a3, 2a1 plus 3b1, 2a2 plus 3b2, 2a3 plus 3b3 can be written as the determinant of A11, B11, B1, C1, A2, B2, C2, A3, B3, C3 multiplied by 0, 2, 1, 3, 0, 1, 2, 3, 0. Since if we have this product A1, B1, C1, A2, B2, C2, A3, B3, C3 times 0, 3, 2, 2, 0, 3, 1, 1, 0. This is the same as, remember, product of two determinants we multiply row by row. So A1 times 0 is 0, B1 times 2 is plus 2B1, C1 times 1 is C1, and then this row, A1 is 0, C1. And then this element here will be this row times this row. So 2A1 plus 3B1 plus 0. This row times this row. So 0 plus 2B2 plus this by this is C2. This by this will have 3A2. This by this is 0. This by this is C2. This by this will have 2A2. This by this is 3B2. This by this is 0. A3 times 0 is 0. B3 times 2 is 2B3. C3 times 1 is C3. A3 times 3 is 3A3. B3 times 0 is 0. C3 times 1 is C3. A3 times 2 is 2A3. B3 times 3 is 3B3. C3 times 0 is 0, but this is 3, which is what we had, 2B1 plus C1, 3A1 plus C1, 2A1 plus 3B1, 2B2 plus C2, 3A2 plus C2, 2A2 plus 3B2, 2B3 plus C3, 3A3 plus C3, and then 2A3 plus 3B3. So therefore, determinant of A1, B1, C1, A2, B2, C1, C2, A3, B3, C3 is a factor, or it's a multiple of the given determinant and the other factor is determinant of 0, 2, 1, 3, 0, 1, 2, 3, 0. And then the second case, 2. So we have been given determinant of 1 cosine of alpha minus beta, cosine of alpha minus gamma, cosine of beta minus alpha, 1 cosine of beta minus gamma, cosine of gamma minus alpha, cosine of gamma minus beta, 1. So know that this is the same as determinant of cosine of alpha, cosine of beta, cosine of gamma, sine of alpha, sine of beta, sine of gamma, 0, 0, 0 times determinant of cos of alpha, cos of beta, cos of gamma, sine of alpha, sine of beta, sine of gamma, 0, 0, 0. And because this is a 0 column, this is a 0 column, so this should give us 0. Or you can say 1 can be written as cos squared alpha plus sine squared alpha, and then cos beta minus alpha can be written as cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Remember, we are using the result that cos of A plus B is cosine of A cosine of B plus minus. Okay, let me just like this minus. So cosine of A minus B is cosine of A cosine of B minus sine of A sine of B. So I'm just writing the expressions given in the expanded form. And this other one would be cos alpha cos gamma plus sine alpha sine. Then this is cosine of beta cosine of alpha plus sine of beta sine of alpha. This is cos, one can be written as cos squared beta plus sine squared beta. Then cos gamma minus beta can be written as cos beta cos gamma plus sine beta sine gamma, which, and then cosine of alpha minus gamma can be written as cosine of alpha cosine of gamma plus sine of gamma sine of alpha. And then cosine of beta minus gamma can be written as cosine of gamma cosine of beta plus sine of gamma sine of beta, and one can be written as cos squared gamma plus sine squared gamma. This, when you simplify, you still get 0. So therefore, that is how you can show that that given determinant simplifies to 0. So the next session will be discussing about conditions for consistency of a system of simultaneous homogeneous equations. Thank you.